Bismillahirrahmanirrahim. We continue our discussion on number system and we will proceed from where we have left from last discussion. In previous lecture, we have discussed a brief introduction about number system, and then we discussed different types of number system that includes decimal number system, binary number system, octal number system, hexadecimal system, and the relationship between these four number systems. Later on, we performed number system conversions, and the first conversion that we performed was decimal to binary. We performed decimal part conversion to complete binary number system, and then the fractional part of decimal number is converted to binary number system. Today we are going to convert binary number system to decimal number system. So let's have a recap what actually binary number system is. As we discussed previously, binary number system, as the name shows, it consists of only two digits. That is 0 and 1. These zeros and ones are written with base 2. Binary number system or binary language is actually computer's own language. This is the only number system that computer understands. So all the digital computers use this binary number system and convert whatever data we enter in decimal form to this binary number. As we all know that computers are made up of electronic components, and those components have either of the two states. One, that means the component is working or on, or 0, that means the component is off. So the data given to computer is ultimately converted to binary form, since computer only understands this binary language. So this is basically computer's own native language. So once the results has been generated by the computer, so in order for the user to understand the results, those binary results are then reconverted back to its equivalent decimal format for the user to understand. Now we are going to perform the conversions, binary number system to decimal number system. We have already performed previously decimal number system to binary number system. Now we are going to perform the reverse. So what is the method to perform this type of conversion? So these are some of the steps that we are going to follow for this type of conversion. First, we have to multiply every binary number with 2 having power 0 for the first position, starting from right to left. So every binary number will be multiplied by 2, with 2 having power 0, starting from right to left. And in next step, we will increase this power by 1, keeping the base same as 2. So the power will be increased and numbers will be multiplied on. At the end, all the products will be sum up in order to get the respective decimal number. So let's see with few examples how we can apply these 3 steps in order to perform binary to decimal conversion. So here we have a binary number. As you can see, it is having base 2 and only zeros and ones are there. So we need to convert this binary number into decimal number system. So as the rule states, we need to multiply every single binary number mentioned here with 2 from power 0, and this multiplication will move from right to left. So this is the number as mentioned in the example, and this is how we are going to perform this multiplication. So first number is 1. So this 1 is multiplied with 2 with power 0, as you can see here. Next number is 0. So this 0 is being multiplied with 2 having power 1. Next number is 0. So this 0 is then multiplied with 2 having power 2, and so on till we reach to the last number, which is 1, and it is being multiplied with 2 having power 8. So all these products are then summed up, as you can see here. All these products are being summed up. So the next step after performing the calculation, as you can see, is the result. Anything that is multiplied with 0 goes to 0, while rest of the answers are here, as you can see. And at the end, after adding up all these products, we get the result 393. So this 393 is actually a decimal number, as it is within the range defined for the decimal number system. So how we write the answer? This is the way how we write the answer: 11001001 with base 2 is equivalent to 393 with base 10. So what we have done in this conversion, every binary number is multiplied with 2 starting with power 0, and this multiplication procedure will proceed from right to left. All those products are then summed up, and the result is the decimal number. Let's do another example. Here you can see we have another binary number 101000011, and we need to convert it into decimal number. So again we repeat the same procedure. This is the number starting from very right. Number 1 is multiplied with 2 having power 0 and move on. So 1 is then multiplied with 2 having power 0. Next number is again 1, which is then multiplied with 2 having power 1. Another number is 0. It is multiplied with 2 with power 2, and so on until we reach to the last one, which is multiplied by 2 having power 7. So the power goes from 0 till maximum. After performing the multiplication, we get this result. So the numbers multiplied with 0 will be resulting in 0, and rest other, as you can see, are in front of you. Then after adding up or summing up the products, we get the result as 163. 163 is now within the range of decimal number system. So this is how we write the answer. 101000011 is equivalent to 163 in base 10. So I hope now you have understood the procedure how we need to convert binary number system to decimal number system. But this was a complete whole number, a complete decimal number. What if we get a binary fraction? Now let's move on. How we need to convert binary fractions to decimal fractions. So this is the rule in front of you for the conversion of binary fractions to decimal fraction. The fractional part is successively multiplied with 2, starting with power -1 for the very first position, starting from left to right. Now the fractional part will be multiplied by 2, but the power of 2 will start from -1. And this multiplication procedure will move on from left to right. In previous examples, when there was a whole number, whole binary number, the multiplication started from right to left. But for the fractional part, we need to start the multiplication from left to right. And the power of 2 will start from -1. At the end, we will add all the results that we are going to get from step 1, and the result will be a decimal number. So here is an example in front of you. Let's perform these steps. As you can see, we have a binary fraction 0.101 in base 2, and we need to convert it to decimal part. So what we have to do is we need to start from very left, from here, and multiply it with 2. The power of 2 will start from -1. So this is the number that we need to convert. Here you can see this 1 is multiplied by 2 and the power of 2 is -1. Then is 0. This 0 is multiplied by 2 and the power reduces 1 by 1. It is then -2, and the last one is multiplied by 2 and the power of 2 is -3. So after performing this calculation, the result is this. 2 raised to power -1 means 1 by 2. So 1 by 2 is actually 0.5. And 2 raised to power -2 is actually 1 raised to power 1 by 2 raised to power 2. That is equal to 1 by 4. So 1 by 4 is multiplied with 0 and the result is ultimately 0. 1 by 2 raised to power -3 is actually 1 by 2 raised to power 3, which is ultimately equivalent to 1 by 2 raised to power 8. And 1 by 2 raised to power 8 is equal to 0.125. So after performing these multiplications and summing up of the result, we get the result as 0.625, which is actually within the range of decimal number system. So we write the results as 0.101 in base 2 is equal to 0.625 in base 10. Let's move on to another example. We have another decimal fraction, binary fraction, and we need to convert it into decimal fraction. The binary fraction is 0.0111. So again, starting from the very left, we need to multiply it with 2, but the power of 2 will start from -1. So here's the number, and this is how we convert it. First 0 is multiplied with 2 with power -1, Then one is multiplied with 2 with power minus 2, another one is multiplied with 2 with power minus 3, and the last one is multiplied with 2 with power minus 4. The result is this in front of you after multiplication, and after summing up of the result we get the final answer as 0.437. So 0.0111 in base 2 is equivalent to 0.4375 in base 10. So this is how we perform binary fractions to decimal fractions. Now let's move on to merge both the parts, the decimal part and the fractional part. So here's the example. We have a binary number having both the decimal part as well as a fractional part. We need to convert it into decimal fraction. Keep in mind that this is the whole number, this one 1101. So we need to perform conversion as per first method, in which we multiplied every single number starting from right with 2, and the power of 2 starts from 0 and so on. While the fractional part is started with from left, from here, and it is multiplied by 2, while the power of 2 is started with minus 1. So here is the number 1101.0111. So what is the procedure? It is in front of you. So this 1 is multiplied by 2 raised to power 0. This 0 is multiplied by 2 raised to power 1. This 1 is multiplied by 2 raised to power 2, and this last one is multiplied by 2 raised to power 3. Now this 0 is multiplied by 2 raised to power minus 1. Since 0 is a non-negative integer, so we have put it towards left side, towards positive side. So 0 is multiplied by 2 having power minus 1. 1 is then multiplied by 2 with power minus 2. Another one is multiplied by 2 with power minus 3, and the last one is multiplied with 2 with power minus 4. So whole part is started from right to left, while the fractional part starts from left to right. The fractional part, the power of 2 will start from minus 1, while the whole part, the power of 2 starts from 0. So after performing the calculation, this is the product of the multiplication, and after summing up of these results, this would be the answer, and the final answer is 13.4375. So how we write it? 1101.0111 in base 2 is equivalent to 13.4375 in base 10. Let's do another example. We have a number, binary number 1011.111. So again, it has both the decimal and fractional part. So the decimal part will be started from right to left, and the power of 2 will be started from 0. While the fractional part will start from left to right, and the power of 2 will start from minus 1. So this is the number, and this is how we perform it. 1 is multiplied by 2 with power 0. Another one is multiplied by 2 with power 1. 0 is multiplied by 2 with power 2, and this last one is multiplied with 2 with power 3. Fractional part, here it is, first one is multiplied by 2 with power minus 1. Another one is multiplied by 2 with power minus 2, and last one is multiplied by 2 with power minus 3. So after performing the calculations, these are the multiplications or the calculation or evaluation of the powers, and then performing the multiplications, this is the result, and after summing up the products, this is the final answer, 11.875. So how we write the answer? 1011.111 in base 2 is equivalent to 11 point, or we can say 11.875 in base 10. I hope you have understood the method how we perform binary to decimal conversion. So this is your assignment. You need to convert these given binary numbers to their respective decimal numbers. Assignment will be uploaded on KCMS and you need to submit it there by its last date. That's all for now. I thank you all.